Next we are going to study about how to balance a redox reaction. If an unbalanced redox reaction is given, how to balance a redox reaction. So there are two different methods to balance a redox reaction. First one is half reaction method. There is one more method called oxidation number method. Here we are studying only about half reaction method. Any one method is enough to balance the redox reaction. So which method we are going to study is half reaction method. So in this video we are going to see only the rules. What are the rules for balancing a redox reaction using half reaction method? Now from the previous sections, it is clear that a redox reaction means there will be oxidation and reduction taking place simultaneously. So there will be one oxidation reaction as well as redox reaction also. So the first point is we can split a redox reaction into two half reactions. What we call them as half reactions. First one is oxidation half reaction and second one is reduction half reaction, OHR and RHR. That will be the short form we will be using. So the first point is we can split a redox reaction into two half reactions, that is oxidation half reactions and reduction half reaction. Now, how we can split, if an equation is given, how we can split that reaction into oxidation and reduction? Yes, before that we have to identify which species is undergoing oxidation and which is undergoing reduction, isn't it? And that we can assess only based on oxidation number. So first thing, when you get an equation to balance a redox reaction is, what should we do first? Assign the oxidation state of each element in the given equation. The first step what we have to do is assign the oxidation state of each element present in the given equation, and from that oxidation state identify the species undergoing oxidation and reduction. Now based on oxidation number, how we can assess which species is undergoing oxidation and which species is undergoing reduction? Yes, that is the third step, and that is increase in oxidation number will be representing always oxidation and decrease in oxidation number will be representing reduction. So after assigning oxidation state or oxidation number, check whether where there is increase and check whether where there is decrease in oxidation number. Now, and after assigning the species undergoing oxidation and reduction, write the two half reactions separately. The one which is undergoing oxidation, write it as oxidation half reaction, and the one which is undergoing reduction, write it as reduction half reaction separately. We have to write them as two half reactions separately. Now, after that, after separating the two half reactions, the next step is look at the increase and decrease in the oxidation number and add the required number of electrons to each half reaction. So after separating the two half reactions as oxidation half reaction and reduction half reaction, the next step is addition of electrons to each half reaction. How should we add electrons to each half reaction? Yes. Now, when we assign the oxidation number, if there is an increase in oxidation number, we have to add electrons on the right hand side. And how many electrons should we add? For example, if there is an increase in oxidation number, if plus 2 becomes plus 4. If there is an increase in oxidation number from plus 2 to plus 4, there is an increase by 2, isn't it? Plus 2 becomes plus 4. Increase in oxidation number by 2, isn't it? So if there is an increase in oxidation number, that much of electrons we have to add on right hand side. So if there is change from plus 2 to plus 4, add 2 electrons on the right hand side. Similarly, if there is a decrease in oxidation number, add the required number of electrons in the left hand side. For example, if there is a decrease from +4 to +4 oxidation state, +4 becomes +2 means there is a decrease by 2. So add that 2 electrons on left hand side. So if there is increase in oxidation number, add electrons in the right hand side, and if there is a decrease in oxidation number, add electrons in the left hand side. That is the first step, adding electrons. Now in the second step, after adding the required number of electrons in the right hand side or left hand side, the next step is if there is any atoms other than hydrogen and oxygen. Don't balance hydrogen and oxygen after adding electrons. If there is any atoms other than hydrogen and oxygen, that we have to balance. So after this, the sixth step is balance all the atoms other than hydrogen and oxygen, and we know how to balance the number of atoms as usual. Now after balancing all the atoms other than hydrogen and oxygen, the seventh step is balance oxygen. How to balance oxygen is, look at the number of oxygen atoms on the left hand side of equation and right hand side, and compare the number of oxygen atoms on both sides. And where there is deficiency of oxygen, if the deficiency is in right hand side, add equal number of water on right hand side. So how to balance oxygen is, add equal number of water molecules where there is shortage of oxygen. For example, if there is 4 hydrogen on the left hand side, only 4 oxygen in the left hand side and 2 oxygen on right hand side. That means right hand side we have shortage of 2 oxygen, isn't it? So on right hand side we have to add 2 water molecules. So how to balance oxygen? By adding equal number of water molecules where there is shortage or deficiency of oxygen. Now the last step is to balance hydrogen. How to balance hydrogen is, before balancing hydrogen we have to check the medium of reaction given. If the medium is acidic, how to balance hydrogen is, in acid medium add required number of H+. In acid medium we are balancing hydrogen by adding H+ where there is shortage of hydrogen. And in basic medium, how we are balancing hydrogen is by adding the required number of water molecules where there is shortage of hydrogen. On whichever side there is shortage of hydrogen, add equal number of water molecules. At the same time, if the medium is basic, we have to add equal number of OH- on the left in the opposite side. Once again, in basic medium where there is shortage of hydrogen, we have to add water. At the same time, in the opposite side we have to add equal number of OH- ions. Now after balancing hydrogen, check the number of electrons in each half reactions, because the next step is balance or make the number of electrons same in both half reactions. In one half reaction if the number of electrons is 2, and in the other half reaction if it is 4, multiply this reaction involving 2 electrons with 2. Okay, so the next step is balance the number of electrons or make the number of electrons same in both the half reactions. And the next one is, after making the number of electrons same in both half reaction, almost the equation is ready. Now what we have to do is add these 2 half reactions. After that, after adding, definitely we will be getting only one single equation. Cancel the common terms, that is the last step. cancel the common terms in the last or the final equation to get the overall equation. So, the final equation what we are getting is called as overall equation. So, these are the steps or rules to balance a redox reaction by using half reaction method. The things will be clear only when we do the examples that we will see in the next video.